Kindly don't present your screen. Mute your audio. கேக்குதாப்பா? You're warm welcome to Mageshwari ma'am. You can present your screen, ma'am. The session will be started at sharply 11 o'clock.
Yes, ma'am. Thank you, ma'am.
Jagdishwari ma'am.
Yes, ma'am. Yes,
Kindly start the session, ma'am. Kindly start the session, ma'am.
Okay,
proceed, you are welcome, ma'am.
Okay, ma'am. Thank you, ma'am. Good morning to everyone. It is my immense pleasure to welcome our managing trustees, Srimati Saraswati Kannayan ma'am, Dr. Priya ma'am, Principal Dr. Punasamy sir, Convener Dr. Anuradha ma'am, and the eminent resource person, respected Mageshwari Purushothaman ma'am of Wales Institute of Science and Technology, of her address on intro on contemporary research on nanotechnology related to COVID-19. I once again welcome you all.
Good morning, most respected participants. I welcome you all once again. In response to the COVID-19 pandemic facing the world, Hindustan Innovative Learning Hub focuses to discuss the issues of multidisciplinary field collaboration with the business and economics emerging trends. We always welcome the scholars, scientists, engineers, researchers, faculties from schools and colleges to join with us and share the new innovative trends in their respective field. Our college, through Hindustan Innovative Learning Hub, presently and proudly organize this 5 days virtual international conference from 15th June to 19th June 2020. The main objective of this conference is to discuss the issues and challenges in multidisciplinary field, and it focuses to aim together scholars, scientists, engineers, researchers, students to share the new innovative trends in their respective field. We start proudly the session by Mageshwari Purushothaman ma'am. Mageshwari Purushothaman ma'am has achieved many things. The first achievement is in her UG, she has got gold medal in Madras University with 96%. Again, in PG also, she is a gold medalist. She received Young Scientist Award in the area of nanotechnology. Madam received Best Presentation Award in NIT. I welcome you, Madam. We proudly welcome you for this session. Usually our sessions may be, it is related to multidisciplinary research. So in the day one topic is, I request all the audience to kindly, Ravi sir, kindly mute your audio, sir. Ravi sir.
Okay.
Ravi sir, kindly mute your audio. Otherwise, you will be removed, sir.
Department of Natural
turn off your meeting. ఏంది నాకు స్పీకర్ అన్న స్పీకర్ ఆన్ చేయన్న సౌండ్ తగ్గిస్తా స్పీకర్
Sorry for the interruption. Day 1, session 1 by Dr. Maheshwari Purushothaman. The topic is intro and contemporary research on nanotechnology related to COVID-19. Day 2, Dr. Kandapan from Taylor University, Malaysia. The topic is expanding the higher education learning space into research opportunities. Day 3, Dr. Sabla Border from Bangalore. His topic is strategic research planning towards innovation and sustainable development. Day 4, Dr. Bhuneshwaran Gunashegaran from Taylor University. His topic is building new sustainability tourism to the pragmatic research approach. And end of the our conference, Day 5, Dr. Rubam Konar from Taylor University, Malaysia. His topic is contemporary research on preparedness of future. So we have chosen 5 different topics in 5 different areas. I feel you can enjoy the international conference. Welcome you all once again. Thank you all. Kind attention to Maheshwari madam. Kindly you proceed, madam.
Thank you, ma'am. My voice is audible, ma'am?
Yes, ma'am, it is audible, ma'am.
My screen is visible.
Your presentation is also, yes, ma'am, your screen is also visible. To Maheshwari Purushothaman in the people list. Kindly to see her in her Maheshwari Purushothaman. If you want to see her presentation, kindly pin Maheshwari Purushothaman's presentation. Thank you, ma'am. You proceed, ma'am.
Yes, ma'am. Good morning to all the participants here. My name is Maheshwari Purushothaman. I convey my thanks to Dr. S. Anuradha ma'am and the whole Hindustan College team for giving me an opportunity to explain about this nanotechnology related to COVID. Thank you. And before we proceed, I just want to give some my topic basics before we enter into this. That's why the title has been listed as Intro and Contemporary Research in Nanotechnology related to COVID-19. My outline of the talk will be introduction, what are nanomaterials, and what are the various synthesis methodologies involved inside that, applications related to nanotechnology, what is COVID-19 and what are the basic symptoms of that, what are the tests that are available in COVID, and how nanotechnology come into this COVID-19, and then the last of the summary for all the things. Now, before we enter into this nano, I think when you say the word nano itself, every one of us, we might be imagining what nano is, why we have to read all these things. Yes, of course, the basic thing, this is what is a field. Your nano comes for the term small. Technology, it is a field. So when you are going to apply your field, the whole thing, you are going to control it based on the properties in a small, in your atomic and your molecular scale. Properties means there will be so many properties such as physical, chemical, electrical, mechanical, optical. So your field where you are going to have the whole thing, you are going to control it in your atomic and molecular. That is what is your nanotechnology. And then the next, of course, there is something related to as nanoscience and nanotechnology. Nanoscience, in a short term, I tell you, you understand about the nanoparticles, the properties. Whereas in nanotechnology, you make it in the form of a structural devices and system by controlling its shape size in a nanometer scale. Now, I'm just talking about nanometer scale. Can you imagine how the scalings will be? Let us have a small example. Now, please look over into the scale. You have a macro, you have a micro, you have a nano. See, when I take some sand grains, I think most of us, we will be seeing the sand grains everywhere, right? You can see it through your naked eyes. Yes, of course. And while you go for red blood cells, which is present in your human blood, RBC, we normally call it to be as. You can't see it through your naked eyes. You require some microscope, an instrument to visualize this. Now, when you come to nano, DNA, deoxy, nucleoxy acids, ribonucleic acid, we normally call it as. Yes? For when you want to view this, it's very, very smaller and smaller in scaling level. So you require a highly designed microscope such as SEM, which stands for Scanning Electron Microscope. So in better, if you want to understand much more, this is how the scaling will be. 10 to the power minus 9 meter. Can you see this? 10 to the power minus 9 meter. This is what is your nano. In a meter, 1,000 millionth of this will be this. So you can imagine how small it will be. When you come to your water molecule, it's nearly about 0.1 to 0.3 nanometer. When you come to RBC, it's nearly about 6,000 to 8,000 nanometer, which is 5 to 8 micrometer level. So similarly, human hair, we all know it's very, very, very small in size to be visible. But can you imagine it is 80,000 to 1 lakh nanometer in nanometer scale. So based on this technology, I think and I hope that you might be having an idea about the scaling right now. Now, what is the next thing? Okay. Based on the scale, nano, etc., everything, this doesn't come as it is like this. So many years it requires for the scientist to build up all this technology. So this comes your history. How? It was first before 2,000 years ago, sulfide nanocrystal. Without knowing it's a nano, the Greeks and Romans, they were using it to dye their hair. Similarly, gold nanoparticles, you can see the material is the same, but the sizes are different. They produce different colors when it is stained with a glass window. It happened before 1,000 years. So can we imagine like that? No, we can't even imagine it's all nano. But there was a famous scientist, his name is Richard Feynman. In December 29, 1959, in one of his important talk, it was a famous talk all over the world in the nanotechnology field. He was talking about one particular concept. There is plenty of room at the bottom. He indirectly tells that this is a smaller level of scaling. So the first concept of nanotechnology began in that era. And later on, in 1974, professor of Tokyo University, Norio Taniguchi, he coined the term nanotechnology. But whatever in theory we were talking about, it will not be interesting for us. So once the nanotechnology field, they came into existence and everyone was knowing about this in the year 1981, when the two famous IBM researchers, Gerd Bennig and Heinrich Royer, when they tried to invent scanning tunneling microscope. When they were doing the molecular research, they were able to find out how to visualize the tiny objects. So in order to base, the base of nanotechnology started in 1981 after this investigation, this invention. And later on in 1985, it was by Harold Kroto, Robert Curl, Richard Smalley. These three scientists, and above, there were so many scientists from Rice University. They were the first one to discover buckyball, which is full of carbon, 60 carbon atom with a pentagon and hexagon structure. And he was awarded, Harold Kroto was awarded Nobel Prize in the field of chemistry for this invention of buckyball. So in 1986, in his famous book, Engines of Creation, Dr. K. Eric Drexler, he used the term, the coming era of nanotechnology. Later on, the famous carbon nanotube. Now, why I say carbon nanotube? See, normally when you use steel, that itself will be very, very high in strength and so much of thing. But this carbon tube, it is nothing but a graphene sheet. When you roll this, it becomes a carbon tube. It will be 100 times stronger than your steel. This was invented by Sumio Lijima in 1991. So this is how nanotechnology came into existence. And now, whatever so far I have told you, you should know who are the scientists, who are the backbone of all these things. So let me see. He is a person, Richard Feynman, who gave the important talk. This is Norio Taniguchi. He was the one who termed the nanotechnology, coined this term. And then the two great scientists who discovered the scanner tunneling microscope, and Henry. See this. And this is the scanning microscope which was first invented by them. And then later on, the buckyball was invented by these two great scientists, Harold Kroto and Richard Smalley. They were the inventors of buckyball. And there comes our professor, Dr. Eric Drexler. And then see the smiling face of this personality. He is none other but Sumio Lijima with his carbon nanotube in his hand, the invention. So not only these scientists, there were so many number of scientists who were behind the screen in developing the nano. Okay, so now I think you might have got an idea about how the history is. Now let's go for the nanomaterials. Nano. Your material can be said to be nano, at least if it has one dimension to be the nanoscale. Based on that, it was divided on three categories: one-dimensional, two-dimensional, and three-dimensional. When you have in one-dimensional your atoms in the nanoscale range, we normally call it to be one-dimensional nanomaterials. So mostly surface coatings, etc. will come under the category. And two-dimensional nanomaterials, mostly your nanotube and nanowires. Fullerenes, your fullerenes are nothing but your buckyballs, right? They come under three-dimensional nanomaterials. And now, I was talking about nanomaterial. Why? For what reason? Is it anything different? Yes, of course. When you consider from a bulk material means it's a larger in scale. When you compare with a bulk material, your nanomaterial are always different. In which way I can say it is different? In which way I can say it is different? Yes, of course. There are two factors which every of the nanotechnology person, they'll be knowing this and they have to know this. The two properties or the two factors which make the nanomaterial to differ from any other material is these two. The increased relative surface area and the quantum confinement effect. So before we go into this, let me give a small example. Now take a cube. Take a cube. You are going to take a cube. Every one of you will be knowing about the area. So this is a one pictorial representation. If I take a cube, the side of the cube is nearly about 2 centimeters. Yes? So when I want to calculate the area of this, it will be 2 into 2, which is 4. Now, how many surfaces a cube will be normally having? It will be having 6 surfaces. So when I want to calculate the surface area, it becomes 2 into 2 into 6, which is 24. Because it's only for one cube we are determining. And the volume level will be a cube. That is side into side, which is 8. So when I going to perform the ratio of surface area by volume, it gives me 3. Now, the same cube, what I'm doing is, I'm cutting the cubes. See the next diagram of this one. So when I start cutting this, the 2 centimeter right now, it becomes 1 centimeter for 1 cube size. So automatically my dimension range is reduced to 1 into 1, but I can see there are 8 cubes are there. The 1 cube, the same volume only there, but that 1 cube, you can see it has been divided into 8. So which means again, my dimension is going to change here, 1 into 1, and my surface area because 1 into 1, 6 surfaces you have, therefore into 6. Total number of cubes is 8. So totally 48. Can you see the surface area is increasing when the size is reducing? This is one of the important factor why the nanomaterial is achieving the properties. They have a unique properties because when compared with a bulk material, and while you compare with surface area to volume ratio, you can see there is an increase in this. This is one of the important one which determines the nanomaterial. And the next one is quantum confinement. Actually, it is a term which we have supposed to make it everything in terms of definition. But right now, I just give you a small explanation which you can easily understand. I hope like that. See the one, can you see here? It is a bulk semiconductor. Yeah, it's a bigger in size. Can you see this? Now, when I'm decreasing the size, can you see the same material? When I'm decreasing the size, can you see some different colors coming around? Yes, that is a property. That is a property of nanocrystals. That's a property of the nanomaterials. Normally, we call this to be as confinement. You have a conduction band, you have a valence band. So the difference between these two energy level, we call it to be as energy gap. This is what is given here, EG, energy gap. Okay. So when you start going to decrease the size of any material, can you see the difference here? The width of this is automatically confining. And the energy levels, you can see there are discrete in energy levels. You can see once a confinement is going on, there is a increase in the energy gap. There is a famous law, E is equal to hc by lambda. So automatically it is understood that if there is a change in the energy gap, automatically your wavelength is also changing. That is why you are able to see different colors because of this confinement factor. Yes, so this forms another important factor which determines that it is a nanomaterial. Yes. Now we understood what is the history behind the nanotechnology, which are the two factors which normally affect this and which tells you there is a differentiation in the nanomaterial, why it is having different properties. It's mainly because of this quantum confinement factor. Now the next thing is synthesis. How are we going to get this? This is our approach. You can see here. There are two approaches. One we call it as top down and the another one is bottom up. From the word top down, you take a bulk one, you start to slice it into pieces. It becomes powder. Again, you start slicing, it becomes nanoparticle. This is what is from the top level, you are downing, you are slicing and make it into smaller level. The another way of approach is bottom up approach. Now what we are going to do? Basically from the bottom, from the down, you are going to construct. It's like a building, basement. So you start making the atoms, you combine them together, they try to form clusters. And these clusters, again, they combine to form together to become nanoparticles. So these are the two synthesis approach that usually go for nanoparticle synthesis. Now, this can be easily described in this. Now, when I'm making out a top-down, yes, of course, there are many advantages. For example, I can produce large-scale production in this. And since it is slicing from the same material, chemical purification is not at all required for this. Whereas in the case of bottom-up, ultra-fine nanoparticles you can make. Because while you are slicing, it cannot be very fine particles. But in the bottom-up synthesis, you can make very fine nanoparticles. And parameter means you can control your temperature, pH, size, shape, morphology, everything you can make the controlling parameter using this bottom-up. much. And another thing, it's very cheaper in technique. The reason is we are going to use mostly liquids, precursors, metal solvents. So basically, those things are all very cheaper when you compare with top-down, because it's an expensive technique. Normally, when you want to slice anything, you require an instrument. So when you are going to make a very, very big material to a smaller level, you require so much of expensive instruments. But there is one disadvantage also there in the bottom-up, which you cannot produce them in a larger scale. So this is one of the things. And I can say top down and bottom up. Suddenly you can't break the item into 2 or 3 like that and all, you can make it small. Or suddenly you can't combine like this. It's not an apple or a thing. So there are some basic experiments. These are the one. When you go to top down, there is something called chemical etching, laser ablation, ball mechanical. This is one of the famous techniques involved. Sputtering and electro explosion. When you come to bottom-up synthesis, you have chemical vapor deposition. Usually it is termed as CVD. And then we have sol-gel process, spray pyrolysis, chemical, electrochemical things. The sol-gel process is a very, very simple technique, which is mostly preferable by everyone in the nanotechnology field. Now, in these two categories, there is a chance of toxic. Toxic means damages, dangerous, hazardous. So the scientists, they started thinking, see, when we were making out chemicals, when we were doing so many chemicals, because combination of chemicals only we are doing, that is the reason it is giving hazardous. So why can't we go for a biological synthesis? That is where the era started with the green synthesis, where they normally use plant materials, where you can use leaves or roots or flowers or fruits. And then you can use bacteria, microorganisms, fungus, algae. So these things you can use to produce nanoparticles. See how beautiful the green synthesis is working out. So the researchers started so many research based on this green synthesis. And this will give you an idea of how it is designed. When you come to physical method, for example, laser ablation, yes, you can see a metal solvent where the laser is pinned inside. In order to make it, you can see these are the different shapes. These are your carbon tubes. These are your nanocapsules, nanospheres. So you can see nanorods. So you can see so many nanoparticles from all these things. And while coming for chemical, it is purely based on chemical reaction, where you have the coating process, you have your synthesis process, and you can work on. While you come to biological, basically biological, like your plant extracts, microorganisms, you can use it and synthesis. But the total ultimate last thing is we try to produce different shapes of nanoparticles. Okay. Now, I cannot give you, because it's an ocean. Once you go inside to this nanotechnology, it's an ocean. Here we can't discuss all the things. So let me give a small. Whenever you say something for a big thing, or just a small thing. So I give one particular methodology. It is called hydrothermal method. The word hydro itself will tell you it is water. To control your temperature here. It's basically a chemical method, which is a bottom-up approach. Here we are going to use, suddenly you can't use, you use some kind of instrument for this. That is what we call it to be as autoclave. Autoclave. Excuse me, Anuradha ma'am. My screen is, PPT is visible.
Sir Ram sir, you please don't present your screen. Sir, it's interrupting our conference, please.
Ma'am, my screen is visible now? Presentation is visible?
Yes, ma'am. Yes, ma'am. Now it is visible, ma'am.
Okay.
I request.
Can I continue, ma'am?
Yes, ma'am. I request the participants to kindly pin Mageshwari Purushothaman's screen. Ma'am, sorry for the interruption, ma'am. You please continue, ma'am.
No problem, ma'am. No problem. Yes, my dear participants. Here we are having hydrothermal methodology. So the instrument which is required for this basic thing is, we call it as autoclave. Now, as a normal person, I'll give you a small detail. Autoclave is a technical term. Imagine that when you are in your home, you use pressure cookers. That is nothing but your autoclaves. This is a simple explanation which I can give for autoclave. Yes. Now here it is lined with a Teflon. Teflon is nothing but it is a polymer compound, which is a trade name given for that, polytetrafluoroethylene. Now you can see here, this is how your autoclave will look like. You have a stainless steel autoclave which is fully compatible there, and you can see a liner which you have Teflon. Now in this you can see this is your inner Teflon chamber, which is written as PTFE. PTFE is nothing but polytetrafluoroethylene polymer. Now why they are using this? Because it is having high density. It's very, very resistant to high temperature, because when you are going to use this experiment till nearly about 200 degrees centigrade, you will be going to make it out. So it has to resist that. So these are the very important points while you are dealing with this hydrothermal technology. I can control my pressure nearly about 3 megapascals. Now this is the one which is required, very important one. You have to close this lid, because while you are using your experiment, you put it inside a furnace, right? And your temperature will be around 200 degrees centigrade or 180 or 80 degree. It depends upon the factor which we are going to use out. So once you are going it suddenly, while you are taking it out, you should not take it suddenly. You have to make it come down to room temperature. Because once you make, will you see example pressure cooker? After having this, suddenly will you open the pressure lid? No one will do that. You make all the pressure to go out first, release them, and then only you open it. The same principle is involved in this Teflon line autoclave. Yes. And now let me give a small synthesis process for titanium nanosheets. Now this is how we normally synthesize nanoparticles. See, there are various different researchers in various methods, in various ways we can synthesize. This is one of the technique which I have given, and I have to, this is taken from a PUBS, which is a famous research article. And they have taken water, ETOH. ETOH means it is ethanol, we normally say. Titanium isopropoxide. You take 25 ml of water and ethanol and start your cellulose fibers to disperse in this. Now automatically after this, you try to put some dropwise addition of titanium isopropoxide, because you want TiO2 nanosheet. So for that, the precursor is titanium isopropoxide. And then you stir for about 1 hour. Okay. And then transfer. Hello.
Ma'am, just a second, ma'am. Again, somebody is presenting.
Yeah,
dear participants, don't present your screen in between. It's interrupting. I request you again and again. Ma'am, sorry, ma'am. Please continue, ma'am.
Ma'am, my voice is audible now?
Your voice is audible. Your presentation is visible, ma'am.
Okay, ma'am. Thank you. Let me continue. Dear participants, so you just start for stirring nearly about 1 hour and then transfer it to your autoclave. Can you see this autoclave right now? And now you keep it in the oven for 80 degrees centigrade nearly for 1 day, which is 24 hours. And then you start cooling them, wash it with ethanol, and then you try to make it in the form of sheets. So this is one of the way of synthesizing your nanosheets, matrix, okay? And now let me go on with, like this, you can make so many number of nanoparticles. Now, based on the size, shape, etc., we have listed here few. The first part of this will be your carbon-based nanoparticle. Your carbon-based nanoparticle, they are nothing but carbon. CNT means carbon nanotubes and fullerenes. Now, basically, you take your graphene sheets, roll it out into a tube where it is nearly 100 times more than that of your steel. The nature why the carbon-based nanoparticle they are used in overall the field is because of their electrical conductivity, their high strength, and their electron affinity nature. The next comes under ceramic nanoparticles. Basically, these kind of nanoparticles are used as in the cancer therapy. Yes, as a drug delivery agent, because they are very, very biocompatible in nature. And in another way, they are made up of oxides, carbides. So basically what happens is, in the case of this, you can control the parameters like your surface area and surface to volume ratio and porosity. That is the reason it can act as a drug delivery. What is the meaning of drug delivery? What is the meaning of drug delivery? It is nothing but, ma'am, my screen is visible?
Ma'am?
My screen is visible, ma'am?
Yes, ma'am. Visible, ma'am. Visible, ma'am.
Okay.
Ma'am, your screen is visible, ma'am.
Okay. Okay, ma'am. So when you come to ceramic nanoparticles, they are the one which is mainly for drug delivery agent. Drug delivery. What is this meaning of drug delivery? See, suddenly you can't take anything inside your human body.
Ma'am, video is not clear, ma'am.
Dear participants, don't interrupt in between. Madam, I can understand whatever you want to say. Please write in chat box. Don't interrupt. So, chat box is noticed. We will take a necessary action, ma'am. Whatever you have queries, please write it in chat box.
My screen is visible, ma'am?
Your screen is visible, ma'am. You please continue, ma'am.
Okay.
Video is not clear as query, ma'am. But in our system, video and audio is very clear, ma'am.
Okay, ma'am. Okay. Can I proceed now, ma'am?
You please proceed, ma'am.
Yeah, thank you, ma'am. So, coming to this drug delivery, directly you cannot take anything inside your human body as it is. So, it is very, very important thing. You require some kind of agent to make yourself. Now, here they are using nanoparticle. The reason is because of their smaller size. When you are going to use a smaller size, they can easily penetrate fastly and they can move inside to that target location. So this is one of the important criteria why the nanoparticles are prescribed in drug delivery agents. But it's a very important thing. It should be biocompatible. The word biocompatible, why we say here is, it should. We are using for human body. We are using for living organism. So it should be compatible, okay with the body structure. So that is the reason. And then we go for metal nanoparticles. Of course, they are from metal precursors. Now, while we talk about a metal thing, it's mainly used in environmental and bioanalytical application. For example, gold nanoparticle. It is coming from a metal precursor. Yeah. And while you are going to do with any synthesis of the sample like SEM, etc., you normally try to coat it with gold nanoparticle. The reason is the electron beam will be nicely coming, so the images will be clear. So that is one of the advantage of why we always coat gold nanoparticles for the samples before you proceed with SEM. The next kind is semiconductor. This forms a clear impact over the total nanotechnology, where you have your semiconductor focusing material, which is a property having a metal also, non-metal also, like your silicon, germanium, gallium, indium, which acts as a gallium phosphide, gallium arsenide, indium phosphide. They are mainly used in electronic devices like imagine your Pentium processors. Photocatalysis. This we will be dealing with in our after the slides. So let me explain to you in that coming slide. So in water waste treatment, so in all these things we can use the semiconductor nanoparticles. Again, while coming to polymeric and lipid based, both of them, they form a very important range in the case of your drug delivery agent, because since they are from polymers and from lipids, they usually give so much of biocompatibility. That is the reason they normally we refer to polymeric nanoparticles. Okay, so now we have seen about lipid, so many nanoparticles. Now, I have told you there is something called SEM. Yes, you can see the images of nanoparticle. This is how it looks like. SEM stands for Scanning Electron Microscope, and TEM stands for Transmission Electron Microscope. Yes, of course. Can you see how small the particles are? Beautiful to look across. This is how in an electron microscope you can view these nanoparticles. It is under 50 nanometer resolution in the case of TEM, where your C and D, they are the gold nanoparticles. A and B will be the SEM and the TEM images of titanium dioxide nanoparticles. Okay, now let's go for applications. Coming to application, there are lots and lots of application. Which application I'll be explaining to you? It's really a thing that I told you. Nanotechnology is another ocean. So when you look for biomedical, you can see anti-cancer, antibacterial, drug delivery. In industrial, you have nanocomposites, drinking water purifiers, for flavors, aromas. In agriculture, you have biosensors. How to improve your soil quality, because that is an important thing. Fertilizers, pesticides. Yes, and in environment, how to make out all the polymers, pollutants, etc., wastewater treatment. So there are so many number of applications available in nano. Now, I have taken titanium dioxide nanoparticle because in our day-to-day life, we are all using this. Just see. This is how your nano powder in titanium dioxide will look like. It's a white nano powder. It's used one of the material in solar cells. You can see Japan, China, so many of them, they are involved in this solar cells. The basic thing is you can use a nanomaterial where titanium dioxide forms a very important one. And photocatalysis is another process. Paints. See, normally what we do is when you are having your homes, etc. and all, you just paint out, you make out all the things. Yes, of course, we all do. But how many of you know that titanium dioxide is involved in that? Only few. Why they are using the titanium dioxide? So normally the principle behind this is there will be more number of germs in our wall. Bacteria may come into existence. Dirt particles may come into existence. So when all these are happening, it may damage your wall structure. Suppose if you are coating that with titanium dioxide, now what it will do is, when your sunlight is entering inside to this, they try to release some kind of radicals, which again, they try to decompose all these dirt particles, bacteria, etc. They try to decompose, break up into the complex form will be broken down into simpler forms. And now once the rainwater comes, it will be washed away. So your wall is protective. This is one of the applications behind your titanium dioxide. Your toothpaste, your rash ointment, everything is involved with titanium dioxide. And now, I was talking about photocatalysis. This is what is photocatalysis. A very important principle. Photo, the word photo will tell you it is light, and catalysis, it is a reaction where it is induced. When you normally have your titanium dioxide, when your UV light is entering from your sunlight, they try to produce electron and holes. They in turn try to produce superoxide radicals. We normally call it as ROS, reactive oxygen species, or superoxide radicals. They are called free scavengers, which means they want more number of electrons. They will try where the electron is, So when such radicals, they are actually toxic in nature. But when they are released out, they will go and search for harmful material. For example, formaldehyde, which is a very, very harmful thing. Now they try to combine and decompose this formaldehyde and give in the form of carbon dioxide and water, which is useful for us. Now can you see how the environment has been polluted? Yes, now it has become free because of this process. So what a plant is normally doing, photosynthesis, a similar concept is did by this. So this is one of the important research involved in photocatalysis. Not only titanium dioxide, you can use another materials also like zinc oxide, etc. for this. The next most basic thing is antibacterial activity. Before we go to our COVID, you should understand this process. What is antibacterial? It's a phenomena that where it either kills the bacteria or prevents the growth of this bacteria. It either prevents or it grows. Now, what happens here is you need to have an antimicrobial property. Normally, your garlic, they contain a compound called allicin, which is mainly responsible for killing this bacteria, fungus, etc. Now, those agents which is used to prevent the bacterial infection, it's mainly known to be as antibacterial agents. We normally have some common terms involved to have this. It can be bactericidal, bacteriostatic, minimum inhibitory concentration, minimum bactericidal concentration. So all these factors will explain to you how to know about this antibacterial. Now, before we enter into this, we have to go for bacteria types. What is bacteria? Yeah, they are single-celled organism. You need something to have a microscope. You need to have something like this. Based on the staining process, your bacteria can be classified in so many ways, based on their size, shape, etc. Now we are taking stain. Stain means you are going to give some coloring. So whether it is going to take up the color or not. For example, gram-positive. There are two categories based on this. Your gram-positive, they will take that crystal violet color dye and it will retain that blue color inside them. So it always looks in that violet coloring. Whereas the gram-negative bacteria, they will never take up this. They cannot retain this crystal violet. So they normally appear red or pink in color. So these are some important bacterial organisms which we have. Gram-positive and gram-negative bacteria. You can see rod-shaped, you can see spherical-shaped, Staphylococcus aureus, Streptococcus pneumonia, Escherichia coli. I think most of you will be knowing in our digestive system we have this E. coli. Otherwise, we cannot be able to survive. So there are some good bacteria also there. And coming to the difference between the structure, please, every one of you listen in this. Can you see a violet color layer there that is called peptidoglycan layer? This is a very important one which gives you a distinguish or a difference between a gram-negative and a gram-positive. You can see the layer is very thin in gram-negative, whereas in gram-positive it is very thick layer. And you can also notice one of the important one, outer membrane, that is present in gram-negative, whereas this is absent in the gram-positive. So these are the differences in cell-wise structure for a gram-negative and gram-positive. Why I discuss this is, when you are using with a bacterial, antibacterial activity, some of the sample, they give preference to gram-positive, some of them will be giving activity for gram-negative. The reason is because of this outer membrane and the peptidoglycan layer, because they cannot go involvement, they can't go inside. So there are some restrictions also for them. So there are various tests available in this. These are the antibiotic tests based on diffusion, dilution. Kirby-Bohr method is a very popular one. And based on this, we can go for experimental analysis. This is how the steps will be. A plate will be there where you can make your agar. Agar is a medium that is required for the bacteria, for their nutrients for the bacteria. And over that, you can use your bacterial inoculum, where bacterial organism will be spreading over there. Then you take a disc, filter paper disc, it will be filter disc, we normally call it as. You have to pinch them over that plate and then leave it nearly for about 24 hours or 3 days or whatever is your time period. And then you can see over the disc, you can see a white color that is called as zone of inhibition, because the growth of your bacteria is prevented in that area due to your sample. So this is how they normally measure it in terms of millimeter using a ruler, and they try to give how resistive it is, whether it is okay, intermediate, or the results are very good. You can predict from these steps. Now, what is the mechanism that is involved in this? Basically, you prepare the nanoparticles. They are very small in size, so they normally easily penetrate inside this. Once they are penetrating inside this, they have a tendency to produce ROS. This is what I told you, reactive oxygen species, ROS, which is your superoxide radicals. The first thing is they try to produce stress. Stress means automatically everything, what is this? You create some stress, not that one. So automatically the whole mechanism, they'll be in stress now. The first thing is it stops the protein. Suppose you are living in your home. No food is there. For 1 day you can tolerate, 2 days you can tolerate. For nearly 1 month you can't tolerate. So the first thing is they stop the protein. They try to give a damage to that. And also at the same time the DNA is also damaged. What will happen? The function of mitochondria, ribosome, everything they stop. And thus it leads to the cell death, which means the bacterial cell, they die. And there will not be any more reproduction from the bacteria. So that is how it's one of the antibacterial action or the principle. Now, let's enter into COVID. Before we enter into COVID, we are all afraid of this term COVID. Yes, coronavirus. What is this actually? CO stands for corona. VI stands for virus. D for disease. And 19 is a year. It's not a thing that is suddenly it has happened. It's a large family of virus. It started in Wuhan in China in December 2019. There are two important diseases before this. We call it as SARS-CoV and MERS-CoV. Severe acute respiratory syndrome and Middle East respiratory syndrome coronavirus. Then WHO in 11th February, they gave the term as COVID-19 for this. What will be the symptoms? You normally have fever, dry cough, tiredness. These are the major symptoms. You can have some rashes on the skin or headache. These are also the symptoms, but it differs from person to person. We can't say, oh, he's having headache, then he's having corona. It's not like that. Yes, it differs from person to person. There are no symptoms also. Yesterday, there was one release from US scientists. They have discovered that before fever, dry cough, and tiredness, the nervous system is first disabled. You can have the thing there. Your nervous system is the one which it is first affected by this COVID. Yesterday, they have given a report based on this. And this is the one which is based on yesterday's report, country-wise. World over 79 lakh of people were affected. USA, 21 lakh. Our India stands in the fourth with 3,32,000. While you come to India level, Maharashtra stands the first with nearly more than 1 lakh. And Tamil Nadu, 42,000. But you can see the death rate, it is 397. And you can also see the recovering rate is more. When compared with other countries, we are somewhat okay, but we have to achieve more. We have to reduce these factors. Okay. Now, this is a beautiful diagram of SARS. It was isolated from a patient in US. You can see the gold color objects, they are nothing but your SARS-CoV-2. It is a SEM image, scanning electron microscope. It was from March 4, 2020. And you can see the 10 images also. This is a one which was done in Pune laboratory in our India. Okay, the first image of COVID-19 in India was released. This is a TEM image. See how it looks, yeah? The dreadful virus is looking like this. Now, what are the tests based on this? You are having two different types of tests. Yes, one is molecular test, which is nucleic acid detection. This is one of the golden tests performed everywhere, and we call it as PCR kit. PCR kit. Now you will understand. PCR kit test. This is the one. And the next one is called antibody test. Antibody means what? Rapid kit test. So these are the two important tests that is available here. We are going to have a small discussion based on this. Now in the case of a molecular test, what happens is they take the nasal swab, okay, and then they try to extract the RNA, yes, and then they will try to convert this into your DNA, which is deoxyribonucleic acid, yes, and then they use the PCR, which is a RT, reverse transcription technique, to amplify, which means the sequence, it will be amplified. Amplified means it becomes bigger and bigger. They will have the same sequence. So which means they can try to match and say, yes, the person is infected with the SARS-CoV or not. This is one of the tests. It is followed all over the world and also gives mostly accurate results for this. But you have to wait for nearly 24 hours or longer time for this. Now coming to antibody. So before we look into this antibody, you should understand what are antibodies. Suppose we are in the home. Yes, we will be enjoying in the home. We will be doing all the things, etc. Suddenly a person from outside, they are coming. He's a foreigner. Will you accept him in this situation? You say, don't come. No, come here. Please don't come here. I'm afraid. You go away. Based on all this, the foreigner is entering into your home. What is the first step we all will do? The first thing is we argue with that foreigner. Don't come. If you come, I'll be very angry. The next thing is you start taking a material. Yeah, if you come, I'll beat you. Yes. You start making all kind of fighting against with that person. This is what is happening in this antibody test. Yes. So normally your human body will be very good. They will function. Suddenly any foreign particle like a virus or a bacteria is inside, which is a harmful thing. Now the body will start, your immune system will start to fight against them. So they try to produce immunoglobulin. There are so many different kinds. We call it as IgA, IgD, IgM, IgG, IgE. So these are several immunoglobulin or antibodies which are produced. Basically for virus, the two important things is Ig capital M, which is immunoglobulin M, and immunoglobulin G. Whenever a first thing any virus is infected, the antibody that is produced is IgM, immunoglobulin M. The next one, that is why it is called a yearly responsible immune response, whereas IgG will be called as a delay one. It will be coming in the second part only. So this is what is a rapid test. They take from a finger the blood serum, okay? They put it into that one. They use a buffer. Why they are using buffer is because you require dilution of the thing. Directly you can't take the blood platelets and put inside there. It will be a problem. So they start to using a buffer where it is diluted, okay? And now we use something called capillary action. We call it to be as a capillary action. So based on this capillary action, it starts making out. You can see there are lines here. Control line, G, M. If your control line alone is present after 15 minutes, you can say you have no COVID, it is negative. Suppose if you, along with control line, if your M testing line is also there, we say it is a positive. Again, a control line with the immunoglobulin G line is also there, we say positive. If all the three lines are present also, we say it is positive. So this will explain to you clearly how the rapid test result will be. When no control line is there, if everything is only G line or M line, totally it is an invalid result. So this is how in the rapid kit it is formed. Now why we have to make out all these things? Why we have to study all these things? Yes, now see this mechanism. You have the sample. Yes, you can see analyte, which is your hemoglobin blood. Nanoparticle. This is where in your COVID, your nanotechnology comes into existence. Your antibody, they get whatever the antigen is your foreign particle. This antigen will be clubbed with your nanoparticle. Your yellow and green color you can see. Now this, wherever your antibody is there, they try to combine, specify that. That is why you can see the red color line in this due to capillary action. These gold nanoparticles are very, very important in this scenario. Yes. Now similarly, this is how your results will look like. Okay. For a positive, C and T, those two test lines will be there for positive. For negative, you don't have anything. But the rapid test, it gives you within 45 minutes your answer. Now, this was a paper submitted in ACS journal. Of course, most of you know about ACS. It's a very, very, very highly dynamic, important journal. In that, Dr. Pan and the research personalities, they have given this part. While you are doing your PCR kit test, it nearly takes 24 hours, etc. But this test, there is no conversion from RNA to DNA. Suddenly it gives out all the results within 10 minutes. But the major thing they have used is nanoparticle, gold nanoparticle. Nanoparticle, they have a tendency because when there is a change in the property, you can visibly have the coloring, different colorings. So while you take the material, it will be purple, violet in color. Once it enters inside to this, and automatically due to the functioning, if the virus is present, automatically it will change it into blue color with the precipitate. So visually you can say within 10 minutes whether it is virus is there or not. The person is infected or not. But this is under the survey with FD. That is your Drug Industry Administration in US. And there is another scientist known as Dr. Thompson Webner from US. They also have made nanoparticles to make it in the form of drug delivery with iron oxides. They are also trying in this nanotechnology field. But due to toxic nature, they are surviving. They are again in the invention to make it as a biocompatible nature for this COVID. So many personalities are making over this. There's a difference, yes. Your PCR kit, it is a swab they are using. Whereas in the case of your rapid kit, they are using blood serum. Processing time will be 24 hours more in the case of PCR, but this is a golden test, which is normally preferred for everywhere. And in the case of rapid test, nearly only 45 minutes it is required. And there are so many challenges, so many challenges. What I have discussed so far is the challenges that are taking place in the nanotechnology. In the film industry you have, in automobile industry you have, in education field you have, in agriculture, in fishery, in so many persons as you have. Yes, not only problems are there, there are some opportunities also because of this coronavirus. How many of you will say this is true? Your father will run away for business, your mother will go for her work somewhere. But now we are all sitting and enjoying that family togetherness. It's one of the opportunity that has been done through this COVID. Now, like webinars, the Hindustan management and Dr. Anuradha ma'am has given me such a golden opportunity to give me what I have learned in my experience. It's really to gain knowledge and also enhancing research. Yes, people are making out. Challenges are there. They are trying from MGR College, University. They are working under this process. So many colleges, they are working under this. They are enhancing the research. So this is how. So whatever may be awareness, please always keep social distancing. Wear mask everywhere. Avoid direct contact with the patients. Normally use sanitizers and show. And also try to have your, in Tamil Nadu, we prescribe in the medicine called Kaba Suba Kudinir. Please make out all those things to develop your immune system so that normally anything will not be in existence. So stay home and stay safe. Before that, let me summarize all the things. We have seen about the introduction. We have seen the synthesis methodology where hydrothermal and applications like photocatalysis and also the human environment, etc. And also about COVID-19 where nearly more amount of people are affected in this. How your gold nanoparticle is related to your coronavirus test. Don't be always panic because of the challenges created by corona. Keep social distancing and make use of the opportunities because of this corona. These are my references which I have, and also thank you. Thank you, dear participants.
Ma'am, thanks a lot, ma'am.
Thank you, ma'am.
Excellent presentation, ma'am. Very nice presentation, ma'am.
Thank you so much, ma'am.
Any questions from participant side?
So much, ma'am.
Hello.
Please, sir, proceed, sir. Sir, please proceed, sir. Any questions from participant side? Any questions from participant side? Ma'am, excellent presentation, ma'am. Can we proceed vote of thanks, ma'am?
Ma'am, let me give some two lines, ma'am, before this.
Please, ma'am. Please, ma'am. Please, ma'am.
I have to give my acknowledgement to my management, Vistas, Wales Institute of Science, Technology and Advanced Studies, Chennai, and to all my Department of Nautical Science, my colleagues, for this great thing. I have to really thank to my guide, Dr. S. Ponusami sir, Department of Physics, SRM University, and Shizuoka University for this nanotechnology collaboration. And I have to thank Hindustan College Management for giving me this golden opportunity. And my special thanks to Dr. Anuradha ma'am for giving me a golden opportunity to give my session regarding nanotechnology to my dear participants. And I convey my special thanks to all the organizers and all the participants, because without them, whatever the session we are working out will never be fruitful. So kindly, I thank all the organizers, Dr. S. Anuradha ma'am, Hindustan Management, and all the participants for this over-responsible and over-fruitful session. Thank you, ma'am, and thank you for the participants.
Ma'am, what you said is very true, ma'am. I have very intellectual set of audience and participants. Whenever I conduct program, I have my own participant list, ma'am.
Yes,
like Pooja Jain, ma'am, Arit sir, Mageshwari Purushothaman, ma'am, and the list is very long, ma'am. They are very connected with Hindustan College of Arts and Science. Thanks a lot,
sure.
Fit.
Thank you, ma'am.
Thanks a lot, ma'am.
I once again thank you, ma'am, for this golden and beautiful opportunity for giving me a chance. Thank you, ma'am.
Thank you so much, ma'am. Can we proceed vote of thanks, ma'am?
Yes, ma'am. Sure, ma'am.
Karnal Lakshmi, ma'am, you please proceed, ma'am. Karnal Lakshmi, ma'am, you please proceed vote of thanks, ma'am.
Yes, ma'am. Thank you, ma'am.
Yes, ma'am.
Good afternoon to one and all. It is my privilege to have been asked to propose vote of thanks. I, on behalf of PG and Research Department of Mathematics, Hindustan College of Arts and Science, Coimbatore, would like to express my gratitude to our managing trustees, Srimati Saraswati Kannayan ma'am, Dr. Priya Satish Prabhu ma'am, Principal Dr. A. Ponusami sir, and convener Dr. S. Anuradha ma'am for organizing this international conference on innovative challenges in multidisciplinary research and practice. I would like to extend my heartfelt thanks to our today's chief guest, Dr. Maheshwari Purushothaman ma'am, for her excellent presentation about the intro and contemporary research on nanotechnology related to COVID-19. Ma'am, the way you have explained about the introduction, history, and approaches, finally, the applications of nanotechnology is very much understandable and interesting.
Thank you, ma'am.
And the things you have shared about COVID-19 is more informative and useful, ma'am. Thank you. I thank each and every one of the participants for joining with us today. Thank you all.
Thank you, most respected participants. Day 2 session will be Expanding the higher education learning space into research opportunities by Dr. Kandapan Balasubramaniam, School of Hospitality, Taylor's University, Malaysia. Thank you all.